Hello everyone, I'm Chiranjeevi. In this video, I'm going to demonstrate Tratteria, an open source project that implements transaction token for enhanced security in microservices architecture. But first, what are transaction tokens? Transaction tokens, or TraTs in short, are shortly cryptographically signed JSON web tokens that immutably preserve the user identity and authorization context of a transaction if the transaction moves through a microservices system. Transaction tokens or TraT help ensure that each step in a transaction is legitimate and authorized. Tratteria is a framework that makes it easy to implement TraTs in your microservices architecture. It provides services for generating and verifying these tokens. This is an architecture of Tratteria. It comes with Tratteria service for issuing transaction tokens and Tratteria agents for verifying transaction tokens. And it is easy to integrate this in existing microservices architecture. So today I'll be demonstrating transaction token in Tratteria and their importance through a story called Hacker in the Vault. This story has two characters. The first one is AlphaStocks. AlphaStocks is a microservice-based stock trading platform that is hosted in a Kubernetes cluster. I will show you how the application looks like. So this is the application. User can log in through Dex IdP provider. Once inside, they can perform stock trading. They can search for stock, they can buy stock, they can sell stock, they can check their portfolio. It's a full-fledged working application. Let me show you by performing a transaction. I'll buy Intel stock. Let me buy 5 of them. Here you go. This is my portfolio. So this is a full-fledged working application. In the second character in the story is Neo. Neo is a hacker who is trying to hack AlphaStock for his personal benefit. So before going into the details of how Neo is able to hack this application, we need to visit some background. So the first thing is, what are microservices? In a typical microservices architecture, we have multiple services communicating with each other inside a virtual private cloud or VPC. Client interact with API microservice or gateway that will forward the client request to internal microservices, and internal microservices communicate with each other to fulfill the client's request. While VPCs provide a layer of security, they are not impenetrable. Malicious attackers can still potentially gain access to various means like software supply chain vulnerabilities or compromise insider accounts. And this is something Neo will exploit today to hack into AlphaStocks. Now let's look at AlphaStocks architecture. AlphaStocks has a typical microservices architecture with gateway acting as an interface of the application. A client authenticates to the application through Dex IdP provider. Once authenticated, gateway provides them session and handles all subsequent requests by forwarding the client request to appropriate microservices. The API of interest today is trading API. This is the API that Neo will attack today, and we need to understand how this API works before understanding how he is able to attack this API. So when a user wants to perform a trading operation, like user will invoke post backslash API backslash order endpoint. The request comes to the gateway service. Gateway service handles things like session management and authentication. Once those are successful, it forwards the request to order service. Order service performs the transaction. For example, if user is buying for a stock, then it will involve things like user paying for the stock they are buying. Once transaction is completed, order service will invoke stock service internal API post backslash internal backslash stocks to update the stock ownership. So if we see here, then there are two types of APIs here. The first one is external APIs that is invoked by the client, and the second API is internal API that is invoked by the order service. So the external APIs are supposed to be accessible to the users, while internal APIs are supposed to be only accessible by internal microservices. So with this background, let's go back to the story. So Neo's plan is to spuriously invoke AlphaStock's internal API. This is how he wants to hack the application. So if he is able to invoke this internal endpoint of stock service, like post backslash internal backslash stocks, then he can update the stock ownership without actually going through the normal transaction process. That means without going through the purchase process. Now we'll see the potential attack vectors that Neo will try to achieve this. So the first thing that Neo does is he will invoke the internal API from outside the VPC. However, this is an easy prevention. AlphaStock's network policy won't let external request to come to internal services. However, Neo is persistent. He uses some other means to gain access to AlphaStock's Kubernetes cluster. So he does some breach through some other means. He compromises an account of a site reliability engineer who was on call. Now he's inside the VPC and things gets interesting now. Since he's inside the VPC, now he has access to the internal API. Now he can invoke that API. However, he is still not there. AlphaStocks have some good security in place to prevent such attacks. AlphaStocks have SPIFFE implemented for service-to-service trust. An stock service only expects other service to hit its internal endpoints. So if Neo makes this call from any other places, stock service will just reject that call. So the new challenge for Neo is to bypass the service-to-service trust implemented in AlphaStocks. To understand how he does that, we need to look at the basic architecture of Spire. So how Spire work is when a service needs to invoke any other endpoint that requires authentication, the service need to first get a token through Spire workload API that proves its identity. For example, if I go back to the diagram of an API, here if you see order service is able to hit the stock service internal API. However, order service needs to proves its identity before it can access that API. Otherwise, stock service will just reject that call. To do that, what order service does is it accesses the sparse workload API to get a token which proves its identity, and with that token, it makes this call, and then only this call will be authorized by stock service. So how Neo bypasses this is using his Kubernetes cluster, he sails into the order service container. Once he is inside the order service container, he will access the Spire agent's workload API to get the token that belongs to order service. With that token, he can successfully impersonate order service. Now things looks like that. He's inside the order service. He invokes Spire workload API to get the token. With that token, he invokes the stock service internal API. And this will go through. There is nothing to prevent this from happening. At this point, Neo can do anything. He can arbitrarily buy any stocks without actually going through the purchase process. Now I'll show you how he does this to the application. So this is Neo's terminal. If you can see here, he has compromised an account of a site reliability engineer who was on call. So he has access to the Kubernetes cluster. So as you can see, he can list the pods. So there are Dex service, order service, stock service, all are running. So let's see the attack that he tried the first. He tried to invoke the API from inside the VPC. So we'll see how he did this first and how it failed. So to perform this, he will launch a container inside the VPC that has functionality to make call request. This command does that. It will spin up a container that has functionality to make a call operation. Now he's inside that container, and now he will make this request. If you look at this request, it is making request to internal backslash stock endpoint, and he is trying to buy 10,000 quantity of certain stock. Yeah, and as you see, this fails. The reason is JWT ASP-ID token not provided. JWT ASP-ID token proves the identity of a service which Neo do not have as of now. So Neo observes this error messages. He will monitor the logs of the application. He will monitor traffic and all those things. And through those things, he figures out there is a SPAR implemented for service to service trust. And next thing he does is he bypasses this. And I'll show you how he does that. To do that, he first goes into the order service. He does that with this command. Now he is inside the order service. The next thing he does is he will invoke the workload API. To do that, he has written a small script that he will copy from his computer to the order service. And now he'll run the command. So now he is able to get the JWT ASCII ID that belongs to the order service. Now he will put that token into the request and he will be able to successfully impersonate the order service. Now he is executing the same command again. He is buying 10,000 quantity of a certain stock. And now he gets a nice looking response. This means he is able to successfully perform the operation. He is able to buy 10,000 quantity of Tesla stock, each worth $800. Now if Neo logs into his application, he will be able to see the transaction he performed in a malicious way. If he goes to his portfolio, then he sees 10,000 Tesla stock of total $8 million of worth. So this is an extremely dangerous attack. So the position that Neo is right now uh, is very dangerous for the company. He can perform anything. He can buy stock. He can sell stock without going through the proper process. So now what happens after this is interesting. Because of the nature of the attack, it's quite difficult to detect such attack. Alpha stocks uncover the breach during their periodic audit. However, because of the nature of the attack and the Neo's proficiency, there is no way they can capture him. So he evades the capture. So the reaction of alpha stocks here is they will implement transaction token to safeguard against such attacks in the future. So this is the new architecture of alpha stocks. So there are few new components here. The first one is Tratteria. So the Tratteria is there are two generate transaction tokens. And the second one are agents. Agents runs alongside each service and they verify transaction tokens. So how this work is, whenever gateway receives a legitimate request, it will call Tratteria service to issue a transaction token. Transaction tokens involves things specific to that particular transaction. For example, who is making this transaction, for which stock, for what operation, and so on. The token is cryptographically signed and has very short expiration time, usually aligning with the API timeout, for example 10 seconds or 15 seconds. Gateway will get the token, it will attach that token into the request, and the token get passed along the request as it goes through the system. What this effectively does it protects the entire microservices architecture provided gateway service is protected. And it is easier to protect gateway service than other service, the reason being gateway can be implemented using robust industry standard solution like APG, AWS, API gateway and all. Additionally, gateway service do not go the rapid development and change the way other services goes. As a result, it's easier to enforce strict security constant at gateway. And the last component here is authchain provider. So Tratteria supports access evaluation through authchain provider. So for before minting the token for each transaction, Tratteria can do access evaluation through authchain API. And authchain API in turn can use platform like Signal to perform the access evaluation. So yeah. So Neo spends his money, and since he knows there is a vulnerability in an application and there is no way they can capture him, he comes back. However, now he faces a completely different situation. All his attempts will be prevented by transaction tokens. So things looks like this now. He's inside the order service. He gets the token to impersonate order service. However, all his attempts will be rejected because the transaction token is invalid. And I'll show you how this goes. First, I will relaunch the application that has transaction token enabled. And now Neo will try to do the same thing. He will go inside the order service. He will impersonate the order service. Now he's inside the order service. Now he will take the same script. He'll run the script to get the token. He'll put that token into the previous request, and he will execute the command. However, to his surprise, he sees TraT missing in the request. Just like before, now he will study the traffic, he will monitor logs, error messages and all. And by this, he figures out like he needs to put a header called transaction token in the request. So what he does is, since he cannot compromise gateway service, he captures some transaction token through the network, and he gets some transaction token. So this is one of the transaction token that Neo has captured through the capture a compromise in some way. So now he will try to perform the same operation using this token. So first he will take the token to impersonate order service, and he will put that into the request, and he will put the token that he has compromised. And he is trying to do the same thing. It's the same request. The request is for Neo, and he is trying to buy 10,000 quantity of Tesla stocks. He will take this request and he will execute this request. To his surprise, he sees invalid TraT. So he gets curious and he wants to know what is happening. So he checks the service logs. Here he sees invalid authorization details. So he gets puzzled. But since he is a good programmer, from the sight of this he realizes this is a dot token. So he parses this token to see what is embedded into this token. Yeah. So here he sees this token seems to have almost all embedded all parameters of the transaction. So it has information about who is making the request. Sherlock is making this request. For what purpose the request is being made? The request is being made for stock trading. In what is the operation? The operation is buy. Which stock is it? For what quantity is it? So at this point, he realizes there is no way he can perform operation for himself because this is a digitally signed token which he cannot modify. So, so at this point, like he cannot do anything for himself, but he still wants to make some damage to the application. So what he decides to do is he will execute an operation that has same parameter as this. Basically, he tries to perform a reply attack now. So he will take this email, he will put this here so that he is executing this request for this person, and so he will make this parameter also the same. The action is buy, also the same, and then the quantity is 5, and the stock ID is 15. Now he will take this request and he will execute this request. To his surprise again, he sees invalid TraT. So he again gets curious and he will go and check the logs of the application. Now he sees TraT has expired. So at this point, he realizes that transaction token embeds all the parameters of the transaction and they have very short expiration time. So at this point, he is hopeless. Even with all the breaches he has made, he is powerless. He cannot do anything. He cannot do anything even with a compromised service. This shows the effectiveness of transaction token. Yeah, one important thing to note here is this is not the only way Neo could have achieved this. In another avenue for this compromise could be software supply chain attack. In this scenario, Neo could introduce malicious code into uh, order service through dependencies or build process, allowing him to achieve the same result. Now I will show you how easy it is to implement Tratteria in your microservice application. To do this, first you need to install Tratteria in your Kubernetes cluster. To do that, you can go to our documentation website, tratteria.io. So inside this, you can go to the section called installing Tratteria. So you can install Tratteria. There are a few simple steps. After that, you have to do some configuration to your cluster. So you have to enable Tratteria in your namespace by putting this label Tratteria enable to be true. After this, in each microservice where you want to inject Tratteria agent, you have to provide the annotation Tratteria inject sidecar to be true. And there are few configuration to do, like in which mode you want to run agent and all. So once you do all those configuration, then you will be ready to use transaction token. After that, you have to write a Kubernetes resource to define how to generate transaction token for your APIs. For example, I'll show you an example of such resource. Yeah, so this is an example of the resource. So you have to write a resource of type kind, which defines how to generate transaction token and how to verify transaction token for an API. So you have to do this for all of your API. If you have 5 action on APIs, then you will have five of this resource. So this writing this resource is quite intuitive. So you specify the path of your API, and here you can define variables using a query parameter or a path parameter that you can use throughout the documentation. Then you specify the method, then you specify the purpose of this API, then you specify how to generate the authorization detail for this API. In after that, you specify how to verify the transaction token for this API. So basically here you can either override the previous values or you can just redefine the new values if a service is doing a little bit different activities. And that's all. And after that, at the end, you have the section for access evaluation. In this section, you can define how to generate the access evaluation request. So this request will be used to evaluate whether a particular transaction should be allowed to be executed or not. Yeah, so that's all. You install Tratteria, you enable Tratteria in your namespace, you write TraT resource for your API, and you have your microservice protected through TraT. Yeah, that wraps up the demonstration for Tratteria. If you are interested in learning more about Tratteria or implementing it in your microservices, you can go to our documentation and you can scan this QR code to go to our documentation. And Tratteria is an open source project. If you are interested in contributing to the project, there are many ways to get involved. You can implement new feature, fix existing feature, or help with documentation. Thank you.